so it's down to me then, isn't it? Good evening all. I think you all know me, so I'm not going to... That fella there. Bit annoyed about this talk, actually. A bit annoyed with me, because I spent a lot of time putting this together. And I knew that somewhere I had got some original documentation that would give me lots of little snippets of information that I couldn't remember. So I did finish the talk off, was rooting around this afternoon, and what did I find? So I was a bit annoyed this afternoon. Never mind. Right, it says, some of you, who came to the last one? I did the history and that. Okay, well, that was fairly basic, and it was more about history of the Ridgeway repeater group and repeaters in Swindon, although it did touch on sort of the basics of repeater. What I'm going to look at a little bit more this time is more technical aspects of repeater, some of the bits, but it is still very general, because to go great depth into some of the technical bits on repeaters, it's actually beyond me some of it. I look at it and think, what does that mean? But okay, so I'm not going to get that deeply involved. I'll try and do a general run through all the various bits and pieces. Let's see if this works. All right, okay, repeaters. That was repeaters one. That was the other one. We had a look at who we are, what we did, what's needed to set up repeater. I'll go into that again. Problems. Who provides repeaters? Who? Yeah, it's not the RSGB, it's repeater groups. And then I went into the history a little bit. And we also said if anybody could help, just let us know. Okay, so what's needed? We're going to look at tonight, yeah, money. What's needed to set up a repeater? What are some of the problems? And there are a few. And what we need. So we need a good high location, preferably. Not everyone has. I mean, WH repeater, when it started, was on the side of a building at Jet at Cullum, which was not at all high. So am I messing you about moving it? Okay, right. So you need a good high location. You need a receiver transmitter. I've put that rather than a transceiver, receiver and transmitter. And you need aerials of some sort. Method of control logic, and that's something we didn't touch on in the last talk at all. We'll mention that a bit later on. So if we have a look a bit further at the high location, well, there's two sorts really. There's the non-sharing site, and wouldn't it be nice? Non-sharing site means that you've no other obvious sources of RF about, which makes life so much simpler. It really does. Or you've got shared sites like the repeaters are on now, and over a period of time you have all sorts of problems. Transmitters near to you, transmitters causing cross-modulation, intermodulation and all sorts. We've had it all at various times. So the site to have on if you can is that one. As I say, chance would be the fine thing. The first site we had the TD on, which I'll show you later on, that was a non-shared site. That was quite good. So that's what it's good to get if you can. So let's have a look. So we'll start just thinking about what life would be like and what we'd need to do on a non-shared site. What sort of issues we might have, if any. You know, no external RF interference, what's the problem? Mainly, it's down to the performance of your own kit. So it depends how good a transmitter and receiver you've got. Not always obvious at first what problems you might get. One of the big problems that really cannot really be a problem. Not only phase noise from your transmitter, but you can get phase noise from the receiver, the local oscillator and the receiver, and all that sort of noise generates a lot of stuff that can be repeated, which is not what you want. So what do we actually mean by phase noise? Okay, now, don't worry about the scales on this. This is only really a representative one. But that could either be a transmitter, it could be a local oscillator, it could be anything generating and producing a frequency. And the beauty about this one is it's fairly narrow and steep, and the shoulders are fairly low. So once you get to about there, then it's relatively level all the way along there. Okay, so that would mean that if you were trying to listen to a signal sort of close in about there, any signal above that sort of level, you should be able to hear. Whereas, look at the difference on that one. Okay, it's nice and narrow up here, but look at these shoulders. So here, if you wanted to listen to a signal about here, then there's quite a big difference in the attenuation. You know, you'd have to have a much stronger signal to sort of get it. And now that's a rig a lot of us would mostly recognise, and that's not so bad. That's the Baofeng UB5. That's not bad. That's nice and sharp, and the shoulder's not quite as good as on the first one. So basically, this is phase noise. All this here is phase noise. That's the bit we want. That's phase noise. It can come from all sorts of places. So what does it really mean in terms, let's try and put some figures on it, which is I had a bit of a struggle with. So if you go back to, actually we can do that. Let's go back to that one. So what we're saying there is that anything above that level, which is about 80 dB, 80 dB down, 80 dBm, however you want to word it. Don't quote me on figures too much. You should be able to hear the signal. Come on. So any signal above that should be readable above the noise. But that really doesn't tell us very much. You really need to translate that to what you'd normally expect the input to a receiver to be, which is normally in microvolts. That's what I understand anyway. An 80 dB or 80 dBm is 22.4 microvolts, assuming a 50 ohm input to your receiver. Now that's a big signal. You know, that's a relatively big signal. So what I'm saying is that with those characteristics that we showed, you'd need quite a big signal to be able to overcome the phase noise in the system. You'd normally expect a repeater to be able to hear less than 2.5 microvolts, or around about 2.5 microvolts. WH, in fact, doesn't meet that at the moment. Have I got some notes on there? Sorry. I put some notes on somewhere. No, didn't. Sorry, I'm mucking your thing. Okay. Yeah, so basically, phase noise is a problem if you want to work weak signals. So there we are. We said we'd normal. Oh, it's on there. I've just put the asterisk on. I've quoted some figures somewhere. Yeah, WH at the moment effectively will hear a signal down to 0.27 of a microvolt coming in. What I haven't put in here, and I ought to mention, squelch, the squelch, or how the repeater opens, has a hysteresis. In other words, it needs that level signal to open it, and it's actually 0.4 something on WH at the moment. But once it's open and held open, then it doesn't keep dropping in and out at that level. It's actually got a hysteresis. It actually goes down to 0.24. So the idea is that if you've got a strongish signal from mobile and he gets in, or you're on your hand, he gets in, if it's marginal or if you're going in and out of buildings, the squelch will hold open right down to 0.24 of a microvolt. Okay, so that's it. So let's go back to 2.5 microvolt and let's work this in dB. That's more like 99 dB. It should be dB really rather than dBm. dB. Whereas we said that we could hear a signal only around about -80. So it looks as though, you know, that gives us a bit of a problem. We've got to do something about it. So they are. If our noise level is around about 75 dBm, we've got to find an extra 24, 25 dB of isolation from somewhere. We've got to cut that noise down by. So how can we do that? Well, the easiest way to do it is, or the obvious way to do it is antenna separation. Usually vertical, one above the other, but it needn't be. It can be some distance. You know, you can have them horizontal. Apart. Now these are the original aerials that were on the water tower at Birdrop Hospital. Okay, quite interesting really, because that was a non-shared site. That was a water tower which is now long gone. Anybody remember it? Anybody been over tower? Yeah, up there. Okay, that was the original. Now, these aerials, there's a lot more to aerials, as we all realise, than meets the eye. That aerial is this fella. This is actually one that came, it's not on the right pole. I'm going to put that up as it's not for me. That's that aerial, and that's a full wave dipole at 70 centimetres. Don't worry about that. That's the construction. We'll take it out, then you can see it. One of the reasons for using that was it was easy to offset, like on a tube like that. It was easy to offset off a pole. Now, if it was a metal structure, it becomes a little bit important how far off the pole you are, because how far off your pole you are affects the radiation pattern. The other beauty about this aerial, as compared to that one's a 5/8 over 5/8 collinear. The difference between that one and that one is that may well not radiate horizontally. You know, some of the collinears in particular, they tend to kick up a bit like that. This one, because it's sort of balanced, if you like, is very flat, so its pattern is like that, so it'll cover down underneath the repeater. One of the issues you have, if you have a high sight, and we did think we had it at Swindon once with TD, well, we did have it. Anybody here when Rob brought the dipole stack in? Well, that dipole stack was meant for flat radiation, whereas a lot of the folded dipole stacks come 5 degrees up. Well, if you're 5 degrees up and you've got stuff 2 or 3 miles away, it's a possibility you might not get it. So that's the reason for that. So if you want to pass that around and have a look at it, be careful you don't poke your eye out with it. Okay. And if anybody wants to know any more about it, you can tell how long ago this stuff was, because all the paperwork I've got, which was the original stuff when we set TD up, is all of that format. None of it's all handwritten, it's all hand-drawn sketches. So that's how long we've been doing it. So that is like that. Also, there's very little radiation up there. It's like a big sort of pattern like that out of these aerials. So it means that anything that one gets from that one is not very much. It gives us a bit of separation, which helps towards the isolation. If you want to read up a bit more about it later on, there's something in there about it. We did, when we started out, have 2 of those, one above the other, but I think we had a problem with one and we couldn't suss out why it worked. So we actually tried, I think that was the receive antenna, we tried a 5/8 collinear and it worked. So that was the setup at, and that was a steel pole. That was a steel pole, yeah. That was mounted on the side. There's a water tower and it had a ladder going up with hoops around it, and it was mounted on the hoops, and it used to wave around something beautiful. Okay, but that was the original TD antenna. So there we've got isolation between that one and that one, which is what we're looking for. So how we're going to measure that isolation? Well, it's fairly straightforward if you've got the right kit. If you put a signal directly into your antenna socket on your receiver, then either get it so that it just opens the squelch, or get an S-meter reading or some other reading that you can very often get a test point to get another reading, and get the signal level. Put the receive antenna back on, and then put your signal generator at the bottom end of the transmit antenna feeder. Increase the signal until the squelch opens the same, or you get the same reading, and that's your difference, that's your isolation. And usually with antennas like that, you can usually get between 20 and 30 dB of isolation. So that's how you get that extra bit from to get you below the noise floor. Okay. Will it work? Well, yeah, it does, but it's not that good. For example, that was the original TD. That was the original Thames Down repeater group repeater on the bird drop site. That was the transmitter. That was the logic. Oh no, the other way around. That's the receiver. That's the transmitter. That's the logic. That was the power supply. Look at all these up here. Now, I think they were all in circuit, but I'll be talking more about those a bit later on. Okay, there's one of them there. Okay, we'll talk about those in a bit. But so we did need to do something else other than the aerial separation. Okay, so it doesn't work that well. So now we've been considering a non-shared site, so it's fairly quiet RF-wise. You've only got your own issues to worry about. On a shared site, of course, there are other sources of noise that will raise the noise floor, and they can and do give us big problems. Okay, what other noise sources might there be? There's a lot more than you might think. Well, there's other transmitters and receivers. For example, when we first put WH on Foxo where it is now, there was some mid-band stuff up there, you know, which is 109, I think it was 109 to 140, 130 something like that. We had all sorts of modulation up there. It's not so bad now. It's mainly gone UHF up there now. Bad connections on a tower. You get the rusty bolt effect quite a lot on towers. You all know what the rusty bolt effect is, where you've got a rusty bolt, instead of conducting, acts like a diode, which sort of acts like a signal generator when it gets any RF in it, and it can broadcast that, and that can give you problems. Poor feeder. That's why on repeaters it's very important. You'll see in a minute, it's very important that you have good feeder. Poor connections in the antenna leads. Look here. Why do I say they're poor? Because they're not that good. They're not that good when it comes to really pushing the need for keeping other RF out and your own RF in. They ain't that good. And there are, of course, some very poor samples around of 259s. Leaky jumpers between components, well, that really follows on from that. If you've got poor feeder and you've got poor jumpers, it all will allow your RF out and other noise in, so you've got to do it. But when I talk about the last one, that's the current WH, and that's the sort of lead I'm talking about. They need to be, you know, that's between the exciter and transmitter, so they need to be good leads, well screened leads, well terminated. It really is noticeable if you have one dodgy connector on a repeater. So how can we clean things up? Well, ensure all our kits installed well, the way I've just been saying. Good screen coax, so you don't want braided coax on the tower. You want solid Heliax, LDF 450, 250, whatever you can get, but decent coax. Good connectors, proper end types for the job, with, you know, either Teflon or PTFE insulation and stuff like that, and well fitted. And the screened internal leads all go to help keep noise out. Of course, noise has got even worse with the advent of phase lock loops in the days when you had all the oscillators were crystal controlled, and that they were fairly clean. You could make them clean by adjusting the drive. Now, with so much synthesized stuff, there's many more little spikes and that all produced that you need to keep out of your system if you want to keep it right. That's an important one. Coaxed earth to the tower along its route. If you're on a tower like WH, it's quite possible, if you haven't got it earthed at the top, but earthed at the bottom, it's quite possible that acts like a inductor or capacitor and can pick up other signals. So you do need to earth your coax. I think ours on WH is earthed about 4 points coming down to the tower. So it stops any sort of interaction between the two. Right, what else? So how else can we clean things up? Well, the other way to clean things up, get more isolation, get rid of the crud, is to filter it out, isn't it? Not that easy. There are many different types. I mean, one of these, I mean, that's a filter. That's a 2 meter 70 cm duplexer, diplexer, call them what you will. So you put transmit receive in there, both 259s, terrible. 70 on one, 2 on the other, and that will actually, that's a filter, or it's a double filter, whatever you like. You've all seen those, I take it? Yeah? You know, I don't know whether that one works still or not. It's lying in my shack, so it most probably doesn't. But they're all right, but they're meant for fairly wide frequency spacing. So you really need, do you want me to take that? That's it, get it out of the way. Don't want somebody poking their eye out with that. We really need something with a bit better performance than they can produce in an ordinary. So it needs to have a high Q. The reason for the high Q is, you know, you get much more selectivity. You can keep signals that you want out, and it has much narrower bandwidth. Because if you're on 2 meters, 144 megs, you know, we're only dealing with 600 kilohertz spacing. Well, that you need to be fairly sharp and a narrow bandwidth to be able to chop one off and let the other one through, sort of thing. So we're really talking about cavity filters, resonant cavity filters to be more correct. Now I copied that because I thought that was about right. The most common is a very high Q or selective resonant cavity. It looks like a large diameter pipe. Well, that doesn't look like a large diameter pipe, but that's a cavity filter. And there's a tuning device on top. And that one, this is quite heavy, by the way, if you decide to pick it up. That one, you press it and then turn it. It is quite heavy, so be careful. Okay. And that is silver plated inside, that one, because that's better. I'll talk about the connections in a minute. Usually 2 coaxial ports used as an input and output. Not necessarily so. More in a while. That is in what you call bandpass mode. In other words, you put a signal in, a signal out, and it allows that signal only to pass through, as long as it's tuned to the frequency. Now that's important because that one, in fact, can I just have that back just a second again? That was meant for 220, that's an old Admiralty cavity, and we bought these, oh, I can't remember, we've got quite a few of these, or had quite a few. How many we've got still now?
7, I think.
And we're still using them, aren't we?
5 of them we are.
Yeah, we're using 5 of them. These were meant for 220 megahertz, something like that, Admiralty filters. And what we've done with them, we've taken them to pieces, and inside there's a piece of double-sided PCB. So now the cavity is that bit down there. Okay, so we've reduced the size of the cavity to make it come up to 2 meters. And that was a standard. And again, if anybody wants to know any more information, you can come and have a look at the old treatise I've got, which I'll try and type up sometime, but God knows when. So that's basically a cavity filter. If in that mode, connection in, connection out, at different frequencies applied to where it got it tuned to, it will reject that frequency. So that works quite well. That is a sort of diagrammatic representation. The one thing it doesn't show is that normally there's some arrangement where that can either be lengthened or a wiper on it, so that you know, you can then tune it. But that's the sort of representation: input, output, and that's basically it. It's as simple as that. And I can't really get my head around this one. I've tried, but that's the equivalent circuit, allegedly. So basically, it's like a big inductor. And the dimensions are such that it fits the frequency you want, and then you've got the tuning device. But quite how that's to, I don't know. So again, just don't take this as being gospel as for their use. These here would be bandpass filters, so they would only let the frequency through that you wanted. These would be notch filters, which would actually take another filter, another frequency that you don't want, actually take it off. Let's get it out of your way, Tim, and then start. So you might have to put bandpass filters in both your transmit and your receive leg, only 600 kilohertz apart, to let those through and reject other frequencies. Okay, we did this one before. To achieve the necessary isolation, you have a mixture of both, and I'll show you a diagram in a minute. Can't remember where I put it, which is quite interesting. So if we want to allow 145650 through, okay, that allows 14560 through. They don't allow 14560 through. That will block that frequency. That will actually block 14565. Come on. But they will allow through that one. So that one, not much should go through there, but whatever does go through there should be drained off by those two, whereas 14565 will go through there. You name the combinations you want. Okay, this is only a rough graph. This is not to do with any of the filters we've actually got, because I actually couldn't find one. I have found one since, of course. That's a typical sort of diagram for a bandpass filter. That's fairly wide. Again, don't worry too much about the frequencies, but they're quite, look at the offset in megahertz, so they're quite sharp, close in. I would hope they would be sharper than that, but the different colours are just different sort of different stackings of filters. It just gives you an impression that that's what a bandpass filter is like. That's that. So basically, those filters or that filter passes that frequency and gradually attenuates other stuff off. Again, not quite as straightforward as that. This is slightly more interesting. This is where it's used as a notch. Now, if you recall, I said that the filter generally has an input and an output. And then I said not always. If you use it as a bandpass, it has. If you're going to use it as a notch, you only use one. And they're different. One you have connected close in for one notch. For example, that's one notch. And see the difference? It's fairly high up there, doesn't attenuate much there. Big, deep attenuation, then attenuates less the other side. Now that would be quite good if you'll say the frequency you want is there, the frequency you want to block is there, you want one that way. If they were the other way around, and your frequency you want there, in other words, depends which way your repeater shifted up or down, then you'd want it that way around. And one, the connection is a T connection close into the filter. The other one is a T connection, but with a quarter wave stub on the end. So there are different ways of connecting filters up. It's not as straightforward as one in, one out. Oh, all right. Okay. So you can have any combination. You have notches, bandpass notches one side, notches the other side. But as with all these things, they're fine, but there's a cost. And I'm not talking only about buying the filters. There's an insertion loss. Whenever you get a filter, you have an insertion loss. So this can vary from sort of 0.5 a dB to 2 dB, depending on the mode. Sometimes it doesn't matter, but you have to allow for it in when you're building a repeater. Right, the design, I'll show you some pictures in a minute. The higher the Q needed, and that means the narrower the bandwidth, the sharper the peak, the larger the internal surface needs to be of both. So the frequency range is determined by length to diameter. That's why we had to shorten that one, because that one was too long. Having said that, oh my God, that was a homemade cavity filter that was used on the original WH. Now it didn't work that well. We had 3 or 4 of these. I'll show you a picture of them in a minute. I don't think I want to pass this one around. Okay. Not quite sure what the internal bit is. It's got Grottiol 259s on top. Yeah, put them down there, thanks. Yeah, nowhere near as good as that, and it's interesting that the dimensions are sort of quite different. But it worked, and for a long time, WH, the original WH, used those filters. Okay, that again was the original WH, first time when it went up on Fox Hill. And there's one of those filters, that one, at the back there. That was another version of the same thing. The reason it's in polythene, for some reason, that one didn't like touching anything. We never did quite fathom out why. So that was the original WH. Look at that. It was all homemade, by the way, the original WH, including the antenna, which was made out of 1/2-inch copper pipe. Which was fine, it worked, and it worked well, but when the riggers came to put it up, they looked at it and said, you really don't want us to put this up, do you? They did. But that was all made by, mainly by Cliff, G2HIF, who sadly now is silent key for some years. So it was all homemade. And that was in a cabinet, a black metal cabinet, on the side of the building at Fox Hill. So when it used to get cold in the winter, we used to have to go up and restart it sometimes. Okay, that's when it moved inside. That's when they redid the building and it moved inside. There's one of those, not quite the same, but there's one of those filters, and there's the one that was the touchy one. Much more modern kit now. Look, we've gone away from the homebrew kit. And then you've got the current WH. Look at the difference in the filters. Look at the absolute difference in the filters. They are commercially built filters, Sinclair filters, 4 of them. What a difference between those and those. But they are very sharp, they are very good. And you can do more or less what you want with those. Yeah, I only found this one yesterday. This is what they call a cutting chart for the filters. When you're putting filters in, these are the 4 filters. And this, which I haven't got round to yet, but this is actually single aerial working. Ignore that for a minute, I'll talk about that in a minute. You've got an antenna, which comes down, goes to a filter, through another filter, and then off to the transmitter. And then you've got another one comes off that device there, which we'll discuss in a minute, through 2 more filters. I don't even know whether, I think they're all bandpass filters. I think it's straightforward as that, but they're bandpass filters. Now that is called a cutting chart, because these lengths are important. The way these filters are made, I said that for notches you needed to have certain lengths. Well, interconnection between the filters you do as well, because it can affect the selectivity of filters otherwise. So these are the cutting charts for the various lengths of that. So it's more commercial now than in the days when that was built. Okay, we talked a little bit about aerials, but let's go a bit more. So far, we've only talked about 2 aerials. So we've had 2 aerials like we had in that picture, where you've got one above the other, you've got a degree of isolation there. We now need to think about, and we said it gave 25 dB of isolation with good spacing. What happens if we only use 1 aerial? Why might we want to use 1 aerial? Reciprocity, in other words, if you've got 2 aerials, there's always a chance that the transmitter will hear more or less than, get to more or less than the receiver will hear. It's the same antenna, it should be the same. Tower space, well, not only tower space, but if you're paying for it, it's important, but also length of feeder. If you've got by another 40, 50 meters of LDF 450, then when you're setting up a repeater, it might count. So there's all sorts of issues that might decide that you do or don't want to use single aerial working. Single aerial working, if you do, it's good, it's much better. But you need more filters and hence more insertion loss, so you need to have a think about it. So we've got 2 aerials, as we said before, we've got a situation like that. But now if we're going to use 1 aerial, we've got the 2 legs, and then we've got this box X here, which we need to know what it is. Now we'd ignore those. Right, X is what's known as a circulator. Hexalator is another word for it. Originally they were called isolators because they literally just isolated one signal from another as well as allowing things to pass through. But then they got modified slightly. And it was only in the 70s, I think, when these things started to come into being. So what is it and what does it do? I don't really know. I don't know totally what it is. It's a ferrite device. The reason I've put plus, they apparently have copper shims either side. I've never seen one in pieces. Have you, Andy, seen one in pieces? Neither have I. But I know that you have to be careful with them because the one at WH, that repeater when we bought it was transported from Birmingham and somebody dropped something and the circulator went off tune. So it's a physical device, but it's mainly ferrite with various connections on. And it allows RF to pass basically in one direction. You'll have to forgive me now if I don't explain this particularly well because I don't totally understand it. Okay. Right, the sort of principle is as follows. You've got 3 or more ports, it tends to be 3. So if you put anything in there, RF in there, it will only go that way. You put RF there, it will only go that way. You put something in there, it will only go that way. Okay? There's a bit more to it than that. That's a similar thing. If you put something in there and send it around, it goes around there. If there's nothing connected to that, it just reflects it. But because it can't go back that way, it then goes round to there. Okay, so that's the general idea, that if you've got something open circuit, it just reflects it, otherwise it sends it on round the loop. So if you're using it in terms of a repeater, that's what you've got. So you've got the transmit which comes in there, it only goes round there, so that gets pushed up to there. Why it won't go around there, I don't know, presumably because that and that are matched, so therefore it goes that way. You get a signal coming in there, that goes round there and into there. It strikes me as being a bit simplistic, that view of it, but that's the basic principle of how a circulator works. So now, and could I find a blooming decent arrow for that? I could not. So now what we've now got this situation. What there is also, but I'm not quite sure where it comes, but there's also what you call a dummy load resistor. Now, where did I go after that? No, I don't want that yet. Okay, now the reason for that is that should anything happen, okay, if all's working normally, transmitter goes up the antenna down into the receiver. But what happens if anything happens to that? Then in theory that goes round and round, and in theory it would go to there. It doesn't quite work like that. But there is a dummy load in there, and they all have a dummy load on, and that basically maintains the impedance. I suspect it's not connected as simply as that. I suspect it's a bit more complex than that, but that's all I could find out. There is definitely a dummy load there that will allow any issues like that going open circuit, will allow that to dump into there, and it still presents 50 ohms to that. So that's the magic circulator. Now, most of you are aware that we have TD, the FM repeater, and TC, the DMR repeater, up on Whitefield. And both those repeaters use one aerial. One aerial, did you all know that? One aerial between the two. It uses one aerial for both repeaters. So this then is what we've got. That's the receiver on the DMR. So you've got a bandpass filter, then it goes to a circulator. That's the FM receiver. Now notice the frequency's not that far apart. We've got a distribution amp, not quite sure why that is, presumably that's just a preamp, is it? Preamp, yeah. Just a preamp in there. A bandpass filter, bandpass. So we've not done any selection in there of getting rid of transmitter noise or any other noise. Then you've got a circulator. So that, if you like, if you remember what we did, that has sort of got these protected. Then signals coming in from an antenna go through a diplex. Now that diplex, I'm fairly certain, is simply to say, right, everything going that way is, look, 433, 434, 430, fairly close. Whereas coming that way, we've got 439. They're far enough apart to want to do a bit of segregation. So those two simply, that allows this group of frequencies through, that allows that group of frequencies. So from the antenna, you have an initial sort of frequency group selection, and then you have the circulator, which works the way we've shown. Interestingly, because that one is relatively close to that and that, we have some notch filters there. And I would suspect that those notches are notching out any component of that in there, and possibly in there. And then we have two bandpass filters. So what have we got? We've got 1, 2, 3, 4, 5, 6, 7. Well, we've got 6 bandpass filters, 3 notch filters, circulated 2 diplexers.
And we had a notch filter fail not that long ago.
Yeah, a notch. Yeah.
And that was causing descent.
Yeah. Yeah, that meant it was allowing some signal through that shouldn't have got. So these things are all doable. Remember earlier on I said insertion loss. Well, that's why that. Because of the insertion loss of this lot, which is not phenomenal, that most probably needs a distribution amp just to up the signal. Again, not as simple as that, because some of these lengths, some of these coax lengths will be critical, not all of them. So it just goes to show what you can do. You can, with filtering, get all the necessary isolation. It's worth saying, of course, that all this kit is all modern kit. It's all kit that's really meant for doing that sort of job. It's not like we started off the original WH I showed you, where it was all homemade. Not implying that homemade is not up to the standard. Give Chris a nudge. Was not up to the standard, but commercial stuff was meant for going onto sites where there was lots of bits and pieces, so that dealt with it much better. So that's the combined TD and TC arrangement. Who set all that up? Paul and?
Yeah, Paul and Roger.
And it took them quite a while, didn't it?
Yeah.
Took them quite a while. That wasn't a 5-minute job to set that up. And if anything goes wrong with that, I wouldn't know where to start. I really wouldn't.
We were lucky when we found out one of the notches that failed because we were a bit in the dark.
Yeah, yeah.
It was only a few weeks ago I went and actually traced that and drew it all out.
Yeah.
It was a nightmare.
Yeah, yeah. And we think that's right, by the way. We think that's right. Because as ever, somebody set it up for us but didn't draw us a diagram. So, okay, so that's the TDTC. Okay, we've done the right, yeah, so that's it. We now have a repeater now then. Now, what we're missing? How to control it. Okay, you whistle your signal up to the repeater, it then does something. Well, we've got to make that work, haven't we? So we have control logic, which sort of fits in there. So what does it do? It listens to the input on the receiver. What does it listen for? RF, anything else? A valid tone, whatever that valid tone may be. It used to be 1750 hertz for about 150 milliseconds, I think. Because you remember the old days when people used to, on a repeater, to whistle a repeater up, and those are long gone. Now you have to have CTCSS, continuous tone coded squelch system. I can't remember now whether or not any of our repeaters listen for audio. Our two repeaters listen for audio. I'm the only the keeper at WH, I should know, but I can't remember. It used to listen for not only the valid tone, but also so many milliseconds of audio. It was to stop people. You had to 1, 2, 3, 4, 5, 6, 7, 8, you know, something like that.
I guess we don't. People do care.
Yeah. I have a feeling we had to drop it with the logic. We'll have a look at that in a minute. So, but that's an option that you not only do you want the valid tone, you want some valid audio in there, like G4LDL listening through, just that sort of length. That was the idea. And of course, the correct CTCSS tone, which for WH and TD, which for this area is? 118.8. Yeah, J, 118.8. For those who don't know what, you all know that the J on the end of the call sign tells you the tone. Yes, no? No, okay. When it gives its call sign in Morse, we used to be able to make it at different tones. So it would go da 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 da. We can't do that with this logic, unfortunately. The J is, you can find a lookup table and it'll tell you what frequency it is. So if you go somewhere else and you get did, get H, you can find the lookout table and look it up. Okay, so that's what that's about. So the repeater, the logic has all that. What does it then do? It switches on the transmitter and it passes the received audio to modulate the transmitter. Then the input drops. It sends the go-ahead pip or pips, and we'll talk about those in a minute. Listens again on the input, any tone, anything on the input. And if there's nothing on the input, in other words, no RF, no CTC, it drops the transmit. For various reasons, it may or may not give its identification. We've dropped the identification on some because that every time, if somebody's using short overs, that just uses a bit more electricity. And electricity is a consideration. At WH it is, TD is not so bad. WH, electricity is a consideration. So anything we can do to, shorten the thing is good. Also, on TD, if I remember right, you don't always like giving the ID because if somebody's using Echolink, it can give you issues. If there is still an input at that stage, then it will go back up to here, won't it? And so it goes on. Meanwhile, while all that's going on, it has to maintain the timers, and the timers for its identity, which we talked about earlier on. It has to give its identity minimum every 15 minutes. Now that ID can either be during overs, in which case it's fast, you know, it's very fast, or if the repeater is idle, it just pops up and gives its identity. So that's all part of the logic. Yeah, the other one it has to do, it has to measure how long there's been the same signal on the input with no drop. Because if somebody just puts a jamming signal on, which has been known, then it would just keep going. But I think it's 5 minutes on WH, if I remember right. TD, I have no idea what it is. So if there's a solid, valid signal on the input, for 5 minutes, it says enough of that, and it switches off the transmitter. There are ways of bringing it back up, but I can't remember. I think I'll have to look it up. I can't remember. Now, sometimes, excuse me, sometimes the repeater does not need CTCSS all the time. Depends how you set your repeater up. Some repeaters, you just want the valid CTCSS to say, okay, I'm a valid signal. I'm putting your CTCS in, now I can let it drop. And once the repeater is opened up, it says fine. Sometimes it says, no, I want it all the time. And the reason for that was to try and stop people messing about quite so much. TD needs CTCSS all the time. WH, I'm not sure if we put it on or not. I'd have to look up the table and see what we did. But it does vary. It also monitors the time, the logic also monitoring for remote commands, and we do have remote commands on WH and on TD, yeah, we've got TD. We can switch it on or off. Okay, I'm not going to tell you what those are, but we can switch it on or off. And WH is quite a useful one. WH, we've got 2 antennas. We've got one at the top, fairly high up, and one lower down. And the higher up one, we did for a long time have odd problems. Whenever it rained, it would get noisy and the signal would drop. So we'd switch to the bottom antenna. Well, I'm not going to say last time it did it, but it's a while ago. But if that happens, we can change antenna. The other thing, if there's a lift and it really gets too much and we're getting stations from too far, we can actually flick over to the bottom antenna, which will give the local coverage still, but hopefully not so much. Okay, so they're the main remote commands that we can do. Now, there's myriads of them in commands. There's several groups of commands. If you want to know more about it, that's the book to do with the logic. Okay, that's got the circuits and the explanation of how to build it as well. Logic was, I might put that in a minute. So we've got timings. These are all settings that you can make. Timings, beacon, remote, general settings, disabling settings, read settings, write settings, test settings, you name them, they're there. That's a typical, that's the list of sort of settings that we can pull down. And we go, and you notice carefully I've blacked these 2 out. Sorry, folks. Not having anybody play with that. I'll just mention 1 or 2 because it's worth knowing. Obviously, the repeater call sign you have to put in. Because it gives its location, we also put in the locator, and we also put in the Swindon, because when it beacons, it does give Swindon IO91 EM. The normal acknowledgement, the acknowledgement is the one when you've had an over and drop carrier, it goes bip, or didard it, or da-di-da, or whatever. So what's WH then?
Didard it.
Didard it, okay. Why is it didard it? It's didard it because, no. Okay, there's another one somewhere that says you can duplicate that. So at one time we had bip, bip, okay, which is fine. But then we've got another one that's on power out somewhere. I see, I can't remember. Another one that says, in the event of power failure, what do I send? And we used to have a di-da-da-dit, P for power. Okay? But of course, because we got the damn thing set we're doing too, we got di-da-da-dit, di-da-da-dit. Well, if you're running on battery, you don't want that twice. So we whipped up and we set it back to 1. Of course, when we sorted the power out and we came off the UPS, you then just got dit. So if you're mobile and you're waiting for somebody to go and the signal's noisy, a bit dit was a bit So we didn't want to do K because TD's got K. So I thought, oh, sod it, we'll put Roger, go ahead, you know. So that's all. But these are the things you can play with. Pip time, we don't use voice, so it's not a problem. Tone burst length, but we don't use that anymore. Latch time, that's the one I was talking about where it needs an input signal for a length of time. Beacon location tells us how often we got to send it. We can set the speed of the Morse code. Somewhere there's one we can set the different speed when it's on. But there's masses of things. If you want to know any more about those, just ask. But the difficulty we have with that is it uses a DOS program, doesn't it?
Yeah.
And if you've got a modern PC and try and run the DOS program to do that, you can't do it. It doesn't like it. So I've got an old PC, you've got one, I think, haven't we? And that's all I've got it for, just in case we have to go up and do anything with that.
You can't even cheat it by slowing the process.
No, there we go. Oh, here we are. Look, there's another one. CTCS only, encode, do not use, or encode. And so there's all sorts of bits we can do. Close call sign. So, and that means when it closes, when it drops, does it give its call sign? Well, and I'm telling you now, this is not valid. Now we've changed it. It's disabled, that is, at the moment. So if we decide we need to change something, we have to go up there, the little old PC, look this up and make some changes. And there is a password as well. So as you can see, there's masses of stuff. So there's a lot more to the logic than at first meets the eye. It's doing lots and lots and lots. Okay, I think we're sort of nearly there, are we now? I think, yeah, that's really. So I haven't gone into great depth. If you want, there's some more bits of paper here you can have a look at. I will eventually try and type them all up because they're quite old, but they're quite interesting, particularly the one on, what's it called? Parameters of duplex operation for repeaters. That's quite an interesting little document, but that was written back in the long time ago, but it's still valid today. Okay, that's fairly short and sweet, but that's a sort of taste of it. Anybody got any more questions? Wow.
Not a question, a comment. I've been testing out an old rig, and it goes into WH with a tone burst, and it carries on, you don't need CCTS.
Yes. No, I think you're right. Have we got the tone burst? Yeah, I think you're right. No, I think it's, well, we toyed with the idea of making it CTCSS all the time, but because we know there are people around with rigs that can't do that, we left it. But if the misuse gets too bad, not that that means a thing, because the people who do the misuse, like the Laughing Policeman Society and that job, they know it all anyway. So let's have a look, see if we can see it. So the tone, it does still take the tone, so tone burst length. Yeah, that may not be the current setting, because this is an old one I pulled up on purpose.
I think it's tone
Works on my old mobile rig anyway.
Sorry? It's what, Andy?
I think it's tone access in the bottom right.
Oh yeah, tone access enabled, yeah, so yeah. Yeah, okay. So what rig is it you're using then?
I've got an old rig, I was just testing it.
Yeah. So it's you been bleeping it up, is it?
But funny enough, I heard someone going, ooh, ooh.
Yeah, well, that's what we used to do. And you used to get quite good at the tone. The trouble with a lot of the older rigs was the tone burst was not, it was, And if that little gate when it was 750, because we used to be able to set how sensitive that gate was, how much either side of 750 hertz it would take. And if that was too tight, then you get somebody, one of these, wouldn't go in, you know. I think Aston Adrian's still got one that comes up with a tone burst. Eh?
Probably.
I think he has, yeah, yeah. So yes, that of course is no longer a requirement, 750. 1750, yeah. So if yeah, because if we didn't have that, if we disabled that, you wouldn't be able to get in with that rig, would you? Yeah, okay. Are you a member of the repeater group, by the way? Are you?
I used to be.
I can see a visit to WH is required. I can see a visit to WH is required here to make a little alteration.
I can say that I also provided some of the equipment.
I know you did. I know you did. I'm not sure we still got it up there now, have we? UPSs? Yeah, I think they've all gone. I think they've all been moved. Okay, any other questions? Are you happy with that? Yeah, go on.
So this stuff you've got here, does it listen on a sound card of a computer and then it also outputs from the computer sound card?
No, it's a totally separate logic.
It's a special
board. It's a special board. Yeah, it's
does it actually control the repeaters? Are they rigs or are they specially designed commercial?
They are commercial, ex-commercial. They're Tate. They are Tate T377 exciter and power amplifier, and I can't remember what the receiver is, but it's proper Tate commercial equipment. So it's meant for a similar sort of thing. But again, if you want a bit more about it, there's a whole book on the transmitter. I don't think we got much on the receiver. Yeah, the original stuff was, say, homemade, and they had fun and games interfacing that. But this is completely separate units now: commercial receiver, commercial transmitter, logic board, which latches in, which plugs in.
And Echolink?
Well, we haven't got Echolink on WH, but we have on TD, and that is done simply via radio. So, because we haven't got it computerized yet. At the moment. So Echolink on here works by, you have a dedicated radio. Whoever on the Echolink has a dedicated radio, which has an interface to his PC, which runs the Echolink program. And that then talks to the repeater, which talks back. That gives you all sorts of issues. And the business of when you have CTCSS on becomes much more complicated when you have Echolink, because your the radio where the Echolink computer is will listen for the CTCSS. So if the repeater is going to beacon or give something at the end of an over, you have to drop the CTCSS. When you're on Echolink, our repeater's call sign must not go out to the Echolink at the other end, because that's illegal. Yeah. So if for any reason when somebody drops, the repeater gives its call sign, you have to make sure the CTCSS is not on that bit. Then the Echolink receiver says, no CTCSS, off. And it's the same with the pips, isn't it, Andy? I think we do. It gets quite complicated with Echolink when we first set it up.
So just to get my understanding of that, so the way our Echolink works on TD, currently, someone has to have a PC connected to the internet running Echolink,
yes,
which is then connected to
a local
radio, which is then doing a radio link into the...
Okay. Correct.
And that's either used to be Rob.
Well, I started it.
Now it's Rob or me, and I should have it running now actually, because Tony's Rob's is up.
Yeah. So that's how it works. The more desirable way to do it is have an internet connection up there, but you know,
you need internet connectivity into the repeater.
That's right. Yeah. If you know.
Sorry. No, it's still away.
I was talking to him this afternoon.
No, it's going away now.
Right.
That's the plan for moving Echolink up there actually, which was probably going to happen a couple of weekends ago, but it just didn't happen.
The advantage with having internet on the site is, as I understand it, if I've got it right, our current Echolink notices of variation are all attended operation, yeah?
Yes.
So in other words, when you're running Echolink, the operator has to be there, like he's there monitoring it now, isn't he? Yeah.
Absolutely.
The NOV says it could be when you've got internet connection on the site, you don't have to be there. It can be unmanned operation, can't it? Which is, I find, is weird. But that's the rules of the game. That's the rules of the game.
Worth noting, if I may, what I think
Yeah,
on the
please
topic
do,
of
yeah.
Echolink. Currently, when Echolink is running, you will either get Rob's call sign or my call sign going over the TD as well. But we have to identify that the link is running.
Yeah.
When it goes to the TD site, it will be running all the time, but there will not be any additional identification
Other than TD itself.
other than TD itself. So just because you may be used to hearing Rob's call or my call, go, TD, Echolink, yeah, let's use
Echolink's on, yeah.
There won't be that identification anymore, so try it anyway.
Does anybody here use Echolink?
I've just started playing with it, but I noticed TD's off at the moment.
It is,
It's not
yeah.
showing as a
Rob's
node. Yeah.
swapped over to me and I haven't started up. So, yeah.
Okay. So yeah, that's Echolink, and yes, it does create some issues with some of the settings on these. Anything else at all?
What power output are we running on TD and WH?
Which side of the filters? there is a difference.
Yeah.
So if I
Yeah.
I can't answer WH.
Yeah.
You can.
Yeah, 12 dBW. I think. No, I think it works out. We're allowed about 20 watts. I think out of the antenna. So no, it's less than that. It's 12 watts out the antenna on WH. It's 12 watts out the antenna. So we have quite a reasonable amount of power at the bottom because we've got all the filtering and we got quite a long feeder. Quite a long feeder. WH.
TD physically out the transmitter.
Yep.
If I remember correctly, is something like 23 watts. By the time it goes through all the filters and it is about to leave the room to go up,
Bear in mind the picture we showed with all the filtering.
it's about 12.
Yeah.
There's a significant loss.
Yeah.
With all
I think
the
WH is about the same, about 12. Not an awful lot, is it? That's why you need the high side, isn't it? You know, that's why you need the high side. And we've got antennas that are gain antennas. That's what you've got to allow for as well, because I think if I remember right, it's ERP. So you can't just say, well, I'll stick 12 watts in and put a 10 times gain. You can't do that. So it's ERP. So and that's limited. That's in the NOV and the spec for the repeater. Okay. Anybody else? No. We've got a long time in Swindon now, repeaters. It seems to be ages. I was surprised myself when I was looking at some stuff, thinking, wow, we've had repeaters here for a long time, and the technology has changed a lot, particularly with regard to circulators. When we first started, we were, oh, what on earth's that? What is it? I mean, the first WHs, well, we didn't even entertain either on TD or WH single area working to start with. Just couldn't even entertain it because we only had such things as filters, cavity filters and otherwise. Then people started producing these circulators and it made life much easier with regard to single area working.
It's an old microwave term.
What?
Circulator.
Circulator, is it? Yeah.
So you get on the old analog microwave,
Yeah.
you used to have them above all of the equipment,
Yeah.
and it'll show you which way it goes, and you'll find there's
Doesn't it?
two waves.
Yeah.
Basically, if you look inside it, it's like a snail shell.
Yeah.
It's got lines
All right. Yeah.
inside it.
Yeah.
I don't know how they do it with the solid state one, but the
Yeah.
old-fashioned one is.
Yeah.
It looks like a.
Was that ferrite again, or plumbing?
Sorry.
Was that ferrite or plumbing?
No, it's plumbing.
Oh, right,
It's
yeah.
aluminium.
More like waveguide then.
Yeah, it is.
Yeah.
It's like
Yeah.
small pieces of
Yeah, well, I don't think these are waveguides. I think these
No,
certainly
well,
certainly the VHF ones. They're not
The idea
waveguide.
comes from microwave. Because
Yeah.
you,
Yeah. Well, like the cavity
you've got to feed it
resonator.
in and feed it back out.
Well, like
Same piece of waveguide.
Like the cavity resonator, isn't it? I mean,
Yeah.
that's basically plumbing again. So these things are all plumbing. So yeah, it's changed. Mike.
One last question. Is my memory right in that WH originally was set up at Harwell?
No, Culham.
Column.
I did say earlier on, the original WH was low level at Culham.
Okay.
and you could just about hear it at Swindon, if you recall.
Yes.
And then backtracking on the last talk, there was a proposal to put a repeater across Aylesbury Way, and the repeater management committee at the time didn't want 2 repeaters, so they were trying to get rid of WH. We had to prove that a repeater at Aylesbury, and it wasn't going to be at Brill then, it was going to be further, would not cover this area. Difficult because MH, those who've been around a long time, Malvern Hills repeater would cover this area. Bristol, you could just about work here, and certainly WR, you could work here in years gone by. It's all changed now. So we managed to prove that you couldn't cover the whole of the Vale of White Horse and Aylesbury with 1 repeater. And then I managed to get a repeater up there, because I worked for Southern Electric at the time. Managed to get permission, and we put one on 2 towers ago. 2 towers ago, yeah, and we managed to get it at Fox Hill. And that made a lot of difference because the coverage was phenomenal. Yeah, the one at Culham, the original White Horse repeater, was more or less a little private group, did it for fun, if you like. So yeah, you're right. And then it moved to Fox Hill and has been there ever since in various guises. Makes you wonder these days though, doesn't it? Is it worth keeping repeaters going? They don't get much use, get nothing like they used to get, nothing at all.
We don't have the truck drivers on the M4 anymore.
Well, you got that, and of course it's nowhere near as easy to put a radio in a car, is it? I mean, in the old days you used to go in, shove it in, drill a hole in the roof, put an aerial on, drill a hole in the bulkhead, shove your 12 volts through. You try doing that these days. It's not so easy, and find a space to put a radio is quite difficult. So I think that's one thing that stopped it. Plus, in general, there's not so much usage these days. There's not so much on VHF, UHF anyway these days. So how long will repeaters keep going? I'm supposed to plug things now and say things like, where is it? Come on.
Give us your money.
Yeah, please support your local repeater group. Oh, Rob said to me, there's nobody else on the bloody repeater group here except you, is there?
No.
Yeah, that's a bit disappointing, isn't it? Yeah, Rob said to me, tell people to join the repeater group and that. Yeah, well, I've got your mark already, yes. 1750s off in a week if you don't. Yeah, it's the same as the radio club, you know. It's funds that keep it going. I think we've got, what did it look like, 20 members at the moment from the last one I saw. Which ain't a lot when you come to look at what we spend each year. WH costs us about £300–400 a year, WH, just to keep that going. Site fees are about just under 150, so mid 100 something, and electricity is another 100, getting off for 200 on that, which we have to pay for. When we started, WH was paying £1 a year peppercorn rent on demand, because it was never demanded. And then Southern Electric gradually handed over control of the site to other people who... Contractors. Yeah, but we're actually lucky, that's not bad, we're still there. If somebody really wanted to push that site commercially and wanted our space, I'm sure they'd get a lot more for it. Although I notice now that it seems to be getting less and less VHF stuff around them. Now it all seems to be going much more UHF and microwave. So from that point of view, we might be all right. We might be okay. You know, because Southern Electric used to have a lot of mid-band stuff up there. They used to have a lot of 470 meg data stuff there. Well, I'm fairly certain that's all gone. They've all gone up much higher than that now. So we might be lucky, won't we? Okay there. But as people start to look at money, because it will get tighter. I mean, there are repeater groups that have had to pack up because commercial sites have said, why shouldn't we charge you commercial rate? You know, you're on our site, commercial rate, or go. They've got to go. The problem being, of course, that if we have to go off that site, we have to remove our aerials and feeders, and we have to pay them to move. So if you shut the repeater down tomorrow, the costs aren't finished by a long chalk. Oh, yeah. Okay.
Thank you, Tony.
Thank you,
Thank you.
guys. Cheers.